Okay, so here we are, the new caps are in. As you can see, looking quite spiffy. So we've got the 280s and the 322s. And they're all nicely lined up. I know it's a small thing, but the values are facing upwards. The leads are nicely dressed. They're properly arranged on the board. Might be, accused of being overly fussy when really nobody's ever going to see it. But I see it. And I couldn't go to bed at night and know that I'd done a bad job of putting them in, even though it might work just fine. I want to know that it looks absolutely fantastic. Test some of these, just for tits and giggles. I'll set it up and be right back. Alright, so here we have a solar capacitor analyzer, the CC2U variety. And the huge advantage of using one of these over let's say an ESR meter or an LCR meter, is that this actually provides the capacitor with a real world experience for its testing. So it will test for leakage and capacitance, but it will do it at up to, well, this one will go up to, it says 400 volts on the dial, but actually it pushes near 500 on the highest setting. So considering these are, what are they, a 450 or a 500 volt, 350 volt DC rated cap. So we can easily test these to their full extent and see what happens. I just love this machine. It's fantastic for testing caps. So, first of all, let's test the capacity. So, here we go, and it should be a 100 microfarad, which will be pretty much right up at the end. And there is the opening of the eye, so that is testing about 70 microfarads. Which, in all honesty, considering the state of it, is actually pretty good. Alright, let's put some voltage across it and see what happens. So we'll put 100 volts on it. And we did get some leakage, but the leakage indicator has gone off, so it is still actually functioning as a capacitor, at least at low voltage. Let's put about 200 volts on it. And we can see there the leakage is on. And so far it's staying on. Yep. That's on. I'm not sure if you can see that in there. But that capacitor is leaking continuously, like a sieve, at just 200 volts. So it is completely stuffed. And this is exactly why you should change the electrolytic capacitors on anything that is in any way vintage. Probably more than 20 years old. Don't even think about trying to keep the capacitors. It's certainly not the filter caps. Small signal caps and things maybe, but power capacitors are just, you're asking to destroy your power transformer and possibly even burn your house down, or worse, burn somebody else's house down. So yeah, just change them. It's very, very slowly starting to reform at 200 volts. And bear in mind, this amp was in use until just a couple of weeks ago. So the leakage has just gone off now. I'm pretty sure if we put 300 volts on it, yeah. And there's a little bit of capacitance there. You can see it draining on the thing. So it was still partially functional, even though it's erupted all over the place. Yeah. Pretty surprising really that it even managed that. Okay, so get rid of that one. Let's try one of the 20 microfarad caps. And you've got to be a little bit careful with this tester to make sure that you're on the 0 setting, because this thing puts high voltage across these test clips. Believe me, you come across 450 volts DC, you're going to know about it. Which is why I'm putting it down. Alright, let's test it for capacity. And there is the opening of the eye, right about there. So it is showing about 13 or 14 microfarads. So there's still a bit of capacity left in that one too. I'll just check the voltage rating. I'm pretty sure it's a 350 volt. Oh no, these are 500 volts. Okay, so we can wind this thing up to the top to check for leakage. First position. Okay. Second, about 250 volts or so, thereabouts. And it's leaking quite significantly. Starting to dim down now. And it will finally stop leaking, I think, eventually. I doubt you can see that in the camera there. There we go, it's just about gone out now. Let's wind it up to about 350, close to 400 volts, about 370 probably. And that's just full-on leakageness. On the full thing, yep. It's leakier than a colander. Discharge, almost immediately discharges. So this isn't a capacitor, it's a resistor. Okay. I think the next thing to do is just double check the value of some of these capacitors here in the power supply. Make sure they're okay and they haven't drifted too much. So, two capacitors hiding down in here should be both 220k. So let's see what they are. Seems remarkably high. Where is it open? Right. Those resistors have been replaced, the doghouse cover is back on, and our work is done, hopefully. Hopefully I won't eat my words in terms of the power supply filter caps. One thing that is important, and I didn't show it there on video, is that between the caps and the top of the doghouse there should be something to prevent the caps from moving around or being able to vibrate, especially important in a combo amp. So we don't want those capacitors vibrating, you know, when you're playing or moving the amp around, because eventually it will weaken the leads of the capacitors, and they can break, and do break, and then, you know, that's a whole world of hurt. So what I actually do is I use some of this. So this is actually the foam that is used for protecting the springs in a reverb tank when it's being shipped. And it comes with, whenever you buy a reverb tank, a block of this foam is jammed inside it. And it's just perfect to cut a couple of strips off it and place them here inside the doghouse so that they're pressed down onto the capacitors, and that holds them very, very firmly. You don't need to glue it or anything like that, and it will last as long as the capacitors do. So perfect. Right, let's get the amp turned over and see what we need to do on the inside. Okay, so now I think the next thing we should do before we start replacing things is make sure that everything that is here that we're going to keep is good. And first and foremost amongst all of that is the power transformer. So I have the amp plugged in through a variac and an isolation transformer and a dim bulb, so it is well isolated and as safe as it is going to get. Obviously, goes without saying, when you're dealing with high voltage, just know what you're doing. If you don't know exactly what you're doing, don't do it. Get someone else to do it who does know what they're doing. Not only could you hurt yourself really badly, but there's the potential there to hurt somebody else using the amp later too, if it's not done properly. So what we're going to do now is just gently bring it up a little bit. There's no tubes in the amp, so it can't draw any current other than the power transformer. And we are going to just make sure that we have, for example, our B plus windings, our filament windings, and our bias is all there. And that will also, by definition, check things like the power switch, the fuse, etc. So let's bring it up a little bit and see what happens. So there's about 50 volts. Let's see what we're getting. Oops, if I can untangle my leads. Yes, we've got 180 volts AC RMS there. That is excellent. So that tells us that our power transformer is functional, at least without any load on it anyway. And if we go between the chassis and here, we have about 15.5 volts there on our bias feed. We check over here. Oops, it would help if we had it on the correct setting. We need DC to check the bias. So we've got minus 15 volts there. Perfect. Let's have a check over here on the B plus output. We have 124 volts DC. Beautiful. So that tells us that all of our supply voltages are functional. Let's go back to AC and we'll check filament voltages. And across the pilot light there, we have 1.8 volt RMS. So that is absolutely fine. That tells us that everything is at least functional. All right, so I think the first thing that we should do is decide exactly what we're going to change in here. Obviously, a lot of it is going to be capacitors. Just find my little pointy thing. Here we go. So the definites that we're going to have to change are the electrolytics. So we've got one here. We've got another one here in the bias. We've got some cathode bypass caps. We've got one here, and two down here. So they are absolutely definitely going to have to be changed. There's also two here in that is the tremolo foot switch control. What else do we need to change? Definitely some of these coupling caps will need to be done. I see that they have the ceramic discs here in the tremolo. They're notoriously unreliable, especially in that sort of situation. They change so much with temperature and everything that I think we'll probably replace those with some film caps just for stability and make sure that the tremolo is actually doing its thing. We will definitely be replacing these two caps here, which are the coupling caps to the output tubes. We definitely don't want any leakage on those, destroying our nice new 6L6s. We'll just double check all these screen resistors, make sure they're all good. They actually look pretty good, I have to say. They don't look like they've been hot or anything like that, but we'll just very carefully check those, measure that they're all well within tolerance. We'll check all of these diodes in the power supply to make sure that they are good. And that is probably a good start. Once we've done that, we can go through. We'll go individually check every single one of these resistors and make sure that they are all correctly within tolerance. That's the wonderful thing about working on an amp that has not been worked on before. You know all of these components, what they should be is what they are. You know what the values should be, and you're very easily able to go through and just make sure that they're all good. I don't know if you can see it there in the camera, but this amp looks like it may have been stored in a slightly damp environment. You can see that the fiber eyelet board here has got a big wave in it here and another one here, and that happens when they absorb moisture and expand. There's not really anything you can do about it. It doesn't really hurt the amp. The only thing it will do if it continues to flex up and down, it can eventually crack some of the solder joints around the components. But to be honest, they actually look pretty perfect to me, so I'm not too worried about that. Right, let's get changing some parts. Well, work has been proceeding apace on the twin reverb, so I thought it would be time to do a quick video shoot and bring you up to speed. So, working along, the first thing we've done is basically take the voltage selector switch out of circuit, and I've rewired the 3-pin power cord, which is this guy here coming in here, and it comes along here, and I have now wired it so that the power comes directly in to the power switch, then out the power switch to the fuse, and then from the fuse to the transformer. And that's not how it was done originally. So this is the better way to do it, because in this case, when you switch off the power switch, the amp is completely off. There's no section of the amp that will have power in it, not even the fuse holder. So that it is the safest way to do it. Then from the transformer, the primary returns and comes out through here, and this blue wire here, which goes back to the mains neutral. Okay, working along the eyelet board, you can see we've replaced the bias filter cap, and also pretty much all of the coupling caps, as well as the electrolytic bypass caps, I have not changed this particular cap, which is in the oscillator ring for the tremolo. We shall check it and make sure that the tremolo is working correctly. If it is, we'll leave it. You can see here we've changed these. Cathode bypass cap down here. Some more coupling caps, a couple of bypass caps down here, and the rest of these coupling capacitors and signal capacitors. I will check all the originals, but I checked a couple of them and they were, well, they didn't inspire much confidence. The two that were in here as the coupling caps to the output tubes were pretty leaky, and they also looked like they'd gotten pretty hot too, so I think they were pretty sad. So I'll check the rest of them and just make sure that we, did the right thing. I've checked a lot of the resistors. They're mostly okay, mostly within tolerance or very nearly. There's one or two I might go back and change, but we'll check that out. I did also replace the mains switch. The original that was in here was a double pole type. It just didn't look right, and I prefer to wire it this way. I feel it's safer. Also, I've gone through and cleaned every single one of the pots and switches on the control panel. I still have to clean the input jacks and the grounding contacts there, so I'll do that. And once we've done all that, I think we're just about right for a gentle power up. So I'm going to clean these jack sockets, get the dummy load ready, and the isolation transformer and stuff like that, and we'll be right back to give this amp its first test. Okay, here we are ready to perform our first power up test on the amplifier after it's been serviced. So just to go through the setup, we have, I don't know if you can see them there, you can just, 2 multimeters here and here. This one will be measuring the B+ plate voltage directly at the output tubes, and this one here, the old flute, is going to be measuring the bias voltage, and we'll be measuring those constantly as we power up the amp. The last thing we want is to lose the bias voltage and have a nice new set of output tubes get destroyed. So as you can see, we've replaced all the various coupling capacitors. We've got a nice new set of tubes in the amplifier, and we are hooked up here to a dummy load. I'll show you that in a moment. And also the normal channel input number 1, we have a 500 hertz tone from a little signal generator, which I don't think you can, well, you can just see it there. This is it here, going into the input on channel number 1. So in terms of how the amp is actually powered, first of all, we have an isolation transformer. So that means that the amp is entirely isolated from any ground reference to the mains for safety, and so that we can work on it with an oscilloscope and stuff like that without causing any problems. It's run through a variac, so we can bring it up slowly, and it's also run through a dim bulb unit with 2 different bulbs of 60 and 100 watts respectively. I'll show you that dim bulb tester shortly. So I'm just going to pause this while I show you the dummy load setup. Okay, so this is the dummy load. It's a 2-channel at 4 ohms per channel, at 250 watts per channel. So it's plenty big enough for testing guitar amps and stuff like that. As you can see, it has a switch down in here to switch between left and right. Actually, we'll monitoring. It's got an output here which feeds up through this coaxial cable into channel 1 of the oscilloscope, and we can see on the screen here on the scope that we have 2 beams being displayed. The top one is channel 1, which will be basically our speaker output from the amplifier, and the lower one is not actually in use right at the moment, but we will use that later on when we do some more testing on the amp. So yes, the dim bulb tester, let's have a look at that. So down here under the bench down here we have the dim bulb unit. So you can see it's got a couple of power outlets there and the 2 bulbs in series, and then we can switch it to either 1 bulb or 2 bulbs, i.e. one or both, and then it's got an in-circuit or bypass switch. So it's currently in circuit on the first bulb, which is a 60 watt, and the power is on. So we're going to bring up the variac and see how we go. Okay, so here we go. I'm now increasing the variac. Oh, I'll just make sure that we have the amp actually powered on. Oops. Yes, we do. And I can already see some plate voltage starting to come up and some bias voltage. 25 volts. 50 volts. 70 volts. And 100 volts on the plates. So what I'm going to do now is turn up the input to channel 1 to say 5 and bring the bass and treble. And we're going to bring the master volume up to about 5 as well, just so we know that the amp will be producing output when we get sufficient voltage to it. And the dim bulb is now starting to glow, which is an excellent sign. If it stays bright, then we know we have a problem. So we've now 200 volts on the plates and minus 21 or minus 22 volts of bias. We're not seeing any output just yet, but we shall carry on. Okay, we are now at full voltage. Okay, so we have the amp on and all our voltages are looking quite reasonable. 422 on the plate, minus 46.3 on the bias. We'll refine those later. Let's have a look at what the scope is showing us. Sorry about the lousy lighting. Okay, so we've got the master volume turned all the way up. Let's bring up the channel 1 input. And there we have it. That nice symmetrical clipping. We can drive it all the way to the top. Perfect. I would say that looks good. We can vary the tone control, so this is the treble. And we can see that has a significant effect. The middle. Which works. And the bass. Which works as well. So the next thing to do now will be to go through and just make sure that the voltages and plate currents of the tubes are correct, and make sure the tremolo and stuff like that works. So I'm going to do that now and I'll bring you back shortly. I now have the tremolo working, and you may be able to see, if I zoom in there, a little roach flashing away. for the tremolo. So that is working great. The reason it wasn't working, I discovered, is one leg of that roach apparently had never been soldered, so I'm wondering if the tremolo actually ever worked on this amp. So far it's the only thing I've found that was actually any kind of possibility of a manufacturing issue. But so far all the voltages look good, the output looks nice, tremolo is working. I haven't tested the reverb yet, I have to hook up a tank for that. Let's have a look at the scope. So if I turn up the master volume, so you get a nice clean sine wave signal. Don't mind the jumping around a bit, that's just my scope not triggering properly. It's only about 70 years old, so it's doing pretty good. And as you can see, as we increase the gain, we can drive the amp into some really nice symmetrical clipping there. And if we dial up the tremolo intensity, you can see we can get a very intense tremolo. In fact, it's very heavily modulating that. And of course we can control the speed as well. So that's minimum speed, which looks about right to me. And we can wind it all the way up to maximum speed. So somewhere, probably around there would be pretty good. So it looks like everything on this amplifier is now working correctly. And the job is now to put it back in its case. We've got some cosmetic work to do on the case. The grill cloth needs to be worked on. The piece of wood that the grill cloth is attached to has basically turned to dust, so it needs to be replaced with a piece of plywood, and the grill cloth moved onto it. We need to do some cosmetic cleaning up of the front of the amplifier, and that's about it. We have a brand new set of tubes in there from JJ, and they're working great. So yes, I think we're just about done. I'll bring you back when I'm doing the grill cloth and we'll see how that goes.